Guys, today we are going to learn about differentiate linear search and binary search taken by Jimmy Joseph. Firstly, we are looking what is linear search and binary search. Linear search is a search that finds an element in the list by searching the element sequentially until the element is found in the list. On the other hand, a binary search is a search that finds the middle element in the list recursively until the middle element is matched with a searched element. Then the working of both the searches, that is the working of linear search and binary search. The linear search starts searching from the first element and scan one element at the time without jumping to the next element. On the other hand, binary search divides the array into half by calculating in array's middle element. And then I'm taking implementation. The linear search can be implemented on any linear data structure such as vector, singly linked list, double linked list. In contrast, the binary search can be implemented on those data structures with two-way traversal, that is, forward and backward traversal. Then we are looking some basic comparisons, complexity, sorted element approach, dataset, and speed, dimension, and efficiency. First, we are looking to firstly we are looking complexity. The linear search is easy to use, or we can say that it is less complex as the element for a linear search can be arranged in any order, whereas in binary search the element must be arranged in a particular order. Sorted element. The element for a linear search can be arranged in random order. It is not mandatory in linear search that the elements are arranged in a sorted order. On the other hand, in a binary search, the elements must be arranged in sorted order. It can be arranged either in an increasing or decreasing order, and accordingly, the algorithm will be changed. By binary search uses a sorted array. It is necessary to insert the element at the proper place. In contrast, the linear search does not need a sorted array, so that the new element can be easily inserted at the end of the array. Next approach. The linear search uses an iterative approach to find the element, so it is also known as a sequential approach. In contrast, the binary search calculates the middle element of the array, so it uses the divide and conquer approach. Next is dataset. Linear search is not suitable for the large dataset. If you want to search the element which is the last element of the array, a linear search will start searching from the first element and it goes on till the last element. So the time taken to search the element would be large. On the other hand, binary search is suitable for a long data set as takes less time. Next is speed. If the data set is large in linear search, then the computational cost would be high and speed becomes slow. If the data set is large in binary search, then the computational cost would be less compared to the linear search and speed becomes fast. Then dimensions. Linear search can be used on both single and dimensional arrays, whereas the binary search can be implemented only on the one-dimensional array. Efficiency. Linear search is a less efficient when we consider the large data sets. Binary search is more efficient than the linear search in the case of large data set. Next, we are looking the differential, looking the differentiate linear search and binary search. There is a table that which separately comparing the linear search and binary search. What's the definition? Linear search is the linear search starts searching from the first element and compares each element with a searched element till the element is not found. Then binary search is it finds the position of the searched element by finding the middle element of the array. Next is sorted data. In the linear search, the element don't need to arrange it in sorted order. In the case of binary search, the precondition for the binary search is the element must be arranged in the sorted order. Next, the comparison is implementation. The linear search can be implemented on any linear data structure such as array, linked list, etc. And in the case of binary search, the implementation of binary search is limited as it can be implemented only in those data structures that have two-way traversal. Next is approach. It is based on the sequential approach. In binary search, it is based on the divide and conquer approach. Then size. In linear search, it is preferable for small size data sets, but binary search, it is preferable for large size data sets. Efficiency. It is less efficient in the case of large size data sets. In binary search, it is more efficient. Worst case scenario. In a linear search, the worst case scenario for finding the element is O. It is binary search. The worst case of scenario finding the element is of log 2n. Best case scenario. In the linear search, the best case scenario for finding the first element is a list of 0, 0, 1. In the binary search, the best case scenario for finding the first element is a list of 0, 1. Dimensional array. It can be implemented on both a single and a multi-dimensional array. It can be implemented only a multi-dimensional array. Thank you. Next, I am going to take a Python implementation of linear search. Firstly, we are inserting a variable ARR. Then we are putting some values to that element 1, 2, 3, 4, 5. Then we are take another variable I and I equal to 3. Then we are uh, create a function called search. Then two arguments are there, ARR and X. ARR is actually our array. That is 1, 2, 3, 4, 5, and X equal to what we are what we are need to find. That is 3. For I in range length of ARR, it means it will check 1, 2, 5. The all elements of the ARR it will check. Then if array of I equal to X, that means um, the element of an array, the all element of an array is equal to 3. When it equal to X, it will returns item found at 3. Next we are just gonna take the binary search Python implementation. Firstly, we are creating a array. ARR just input some values 2, 3, 4, 10, and 14, and we putting a next value or another input, that is X equal to 10. Then we are calling a function result equal to binary search. ARR. ARR, it is the old element of a array, and the 0 is the 0 syntax, and the length of array minus 1 is the last index, and X equal to X 10. Then we are checking if I greater than or equal to low. Its I is the last index and low is the first index. If high greater than or equal to low, then we are going to check mid equal to high plus low by 2. That means um, we are find the mid value. If the mid value equal to x, that means the mid value equal to 10, then it returns mid. If ARR mid is not equal to x, then it goes to the ARR of mid greater than equal to x and return binary search. It will true and it returns the element is present at index. We are checking the input, checking the output. Yes, element is present at 3.